The problem is, a quarter circle with radius 4 is centered at the origin and is in the first quadrant bounded by the x and y axis. The line x is equal to 2 is drawn. We wish to find the area of the portion of the quarter circle to the right of the line x equals 2. Well, conveniently someone has already drawn a figure for us. Well, what do we know from this? We want to find this area, right? The area of this shaded portion. And we know that this is 2, this is 2, and this is 4, because we know the radius of the quarter circle is 4. And because it's bounded by the x and y axis, this is a right angle, and it's also a quarter circle. So we know the area of the quarter circle, and we know its radius, because we know it's but how can we use this to find the area of the shaded region? Because the shaded region isn't a quarter circle. This side is shorter than this side, and it's not a rectangle or any other nice shape we know, right? Well, the motivation to this problem is, let's consider drawing this line over here, from here to here. Now, because it's a radius of the quarter circle, we know this must also be 4. And this we know is a right angle because it's the line x is equal to 2. Well, if the hypotenuse is 4 and a leg is 2 of this right triangle, it has to be a 30, 60, 90 right triangle that satisfies the 30, 60, 90 relationship. So just a quick refresher, if we have a triangle where this angle is 30 and this angle is 60, then if this side length is x, this side length will be x root 3, and this hypotenuse will be 2x. So we can apply this here, and we notice that because this is a 30, 60, 90 triangle, this angle must be 60 degrees. Well, how does this help us? Well, notice this isn't just the angle of this triangle, it's also the angle of this sector cut off by the arc, if you see where my cursor is going. And because it's 60 degrees, well, 60 out of 360, which is the total number of degrees in the circle, well, that's just 1 out of 6, right? So the area of this sector bounded by this line and the x-axis is going to be 1/6 the area of the total circle. So that area is 4 squared times pi, and that's going to be divided by 6. So that's going to simplify to 8 pi over 3. And we're going to keep that in our minds for now. But that's still not what we want. We want the area of the shaded region. And so far we found the area of this sector. Well, what we should notice is that if we subtract this triangle from the sector, then all we're left with is the area of the shaded region. Well, let's use our 30, 60, 90 relationships. Because this is 2 and this is a 60-degree angle, we know that this height must be 2 root 3. Then you can apply base times height to this triangle and over 2. So 2 times the square root of 3 divided by 2, that's going to be 2 times the square root of 3. And that means the area of this triangle is just 2 times the square root of 3. And so we subtract that from our sector of 60 degrees, and you get 8 pi over 3 minus 2 times the square root of 3. And that is indeed our final answer. Thank you for listening.